Hello everyone, let us discuss about multi-terminal HVDC systems. So coming to introduction part, what is a HVDC? A HVDC link is used to transmit the bulk power over long distances since there are reduced I square R losses. So what are the types of HVDC systems? There are three types basically. We have back-to-back systems, two-terminal systems and multi-terminal systems. So back-to-back systems, these are the systems which connects two asynchronous AC systems where converters are connected to back-to-back. So what are two terminal systems? Two separate converters stations, that is rectifier or inverter connected by a DC link. This link can be monopolar, bipolar or homopolar. This type of system are called as point-to-point link, that is there is no tapping intermediately. So multi-terminal systems. These are systems which uses multiple transmission lines to connect more than 2 points. These can also use the monopolar, bipolar or homopolar as a DC link. So let us see in detail about multi-terminal HVDC systems. This type of HVDC configuration uses multiple transmission lines to connect more than 2 points. So there are multiple terminal stations, each with their own converter connected by the HVDC transmission line network. Some of these converters operate as rectifiers while others act as inverters. The power supplied by the rectifiers combination is equal to the combined power received by the inverter stations. So in multi-terminal HVDC systems, we cannot use AC circuit breakers on the AC side because it will de-energize the whole DC network instead of isolating the specified line having fault or scheduled maintenance. Therefore, MTDC system requires multiple DC switchgear that can safely de-energize the circuits or isolate in the case of maintenance work or fault clearance. So in multi-terminal HVDC systems, it is required to balance the system in such a way that the amount of current supplied by the rectifier stations is equal to the amount of current supplied by the inverter station. In case in case of high demand of power from any inverter station, the DC power is ramped up to meet the requirement. In doing so, it is necessary to monitor and control the voltage supplied by the inverters in case of overloading. The MTDC systems are reliable in case of forced outage, that is, unexpected power failure from one of the many generation stations, the power supply relocated through another converter station. So let us see about the types of MTDC systems. So there are two main types. One is series MTDC system, the another one is parallel MTDC system. Under parallel MTDC systems, there are two types. One is radial MTDC system, another one is mesh MTDC systems. Let us see one by one. In this type, multiple converter stations are connected in series with each other. Just like in series circuit, the current flowing through each of the converter stations remains the same, which is set by one station, while the voltage drop may divide among the converter stations. And it is an extension of two-terminal HVDC system with multiple converter stations in series as shown in the diagram. The converter stations are usually lower capacity than the one used in parallel MTDC systems. The system usually uses monopolar DC links where the line is grounded at only one point. However, a grounding capacitor can be used at, at any other line for protection against transients. So the power flow in this system is a little complex as compared to the parallel MTDC system, because a parallel MTDC system can control its power flow by injecting current in a specific line, while in series MTDC system the power flow control is done by voltage control at each terminal station. In a series MTDC system, the power flow reversal can be easily implemented using both VSC, that is voltage source converter, and CSC, current source converter. And in case of fault or scheduled maintenance in a specific line, the whole DC network will face a blackout. Therefore, just like a two-terminal system, the circuit breaker on the AC side is used to de-energize the DC network. So let us see about parallel MTDC systems. In the parallel MTDC systems, there are multiple converter stations or load stations that are connected to a single converter station that supply power to the whole DC network. Just like a parallel circuit, the voltage remains constant or the same at the all inverter or load station that is set by one of the converter stations. So according to the power demand at each load station, the current is adjusted to balance the current supply. These terminal stations are generally of higher capacity than the series network. So the power reversal can be done with either voltage reversal or current reversal. In parallel MTDC systems, the voltage reversal using CSC based terminal stations affect all converter stations. Thus, we need to implement a sophisticated control and communication system between these converters. However, if the power reversal is done using the current reversal technique, it will be much easier to realize. It is the reason VSC, voltage source converters, are preferred in parallel MTDC system instead of CSC. And since the voltage remains constant in the VSC MTDC systems, the current ratings of the valve converter decides the power rating of the terminal station. It offers a wide range of power flow control in the DC network by injecting current in the specified line. So, and the main feature of this parallel MTDC system is, if there is a fault in any terminal stations, the remaining DC network does not get affected. And also, in case of expansion of DC network, the power supply does not need to be interrupted, because the new terminal is installed in parallel from these existing lines. The installation coordination in such a system is far more simple than in a series system, because the voltage remains constant. So let us see about the one type of parallel MTDC system, that is radial MTDC system. So this is the diagram of radial MTDC system. It is a type of parallel MTDC configuration where a break in a transmission line or removal of one link will cause interruption of power supply to one or more than one converter station. So in radial MTDC system, if you remove any one link, the system will not work. Because of such interruption in power supply, these systems are unreliable as compared to mesh or ring type MTDC systems. Let us see about mesh MTDC systems. So in mesh or ring MTDC systems, the inverter stations are connected with a single rectifier station in mesh or ring formation, where a break in one transmission line or removal of one link does not interrupt the power supply to any inverter stations. So this is the diagram of the mesh MTDC systems. As you can see, the removal of any link will not interrupt the power supply to any converter. In fact, the power will be routed through the other links. However, the other links must be designed to withstand the power transmission with power losses. So let us see about some applications of MTDC. It connects multiple DC renewable energy farms to multiple power grids, connecting multiple offshore wind farms to the power grid. It transfers the bulk power from multiple remote AC generating stations to multiple load centers. It allows interconnection between two asynchronous AC power systems. The power supply reallocation in case of power failures in one of the generating stations. It can be used to offer more power to a heavily loaded AC network by using one rectifier and multiple inverters that injects power into the said AC network. It offers flexibility for power tapping at multiple points. Thank you.